Find the values of x and y that make this statement true. Well, taking a look, we can see that we are dealing with complex numbers, a combination of real and imaginary numbers. So, let's start by recalling the equality of complex numbers. Two complex numbers are equal to each other if their real parts are equal to each other and their imaginary parts are equal to one another. So here, if we can identify the real and the imaginary parts in each of these complex numbers, we can set those real parts equal to each other and the imaginary parts to each other and solve for x and y. However, because we have these parentheses, we have to distribute the 4 into the 2 and to the 3i. So in this case, 6x plus 2y. And our second step is to simplify. So here, the 6x plus 2yi is already simplified as much as it could, but here we have the 2x, and we would distribute the 4 into the 2 and the 4 into the 3. So we would have 2x plus 8 plus 12i. Now, we can identify our different parts. Here, the 6x would be a real number, so that would be r. And also, the 2x plus the 8 are also real, because they don't include an I. But the ones that do include an I, those would be the imaginary numbers. So it would be this, the 2yi would be imaginary, and the 12i would be imaginary as well. Now, we would set them equal to each other. So now, we have 6x equals 2x plus 8. So now, we are going to find what the value of x is. So this would be solving for the real numbers. So here, we would subtract 2x minus 2x, and then that would give us 4x is equal to 8. And here we just divide by 4 both sides, and here this would cancel out, and this would reduce to 2. So x equals 2. And in the imaginary side, we have 2y is equal to 12i. So now, what we would do is we would just divide by 2i. So divide everything by 2i, and this cancels out, and this would cancel out, and then both of these i's would cancel out. So y is equal to 6. So now, in order for this to be a true statement and these complex numbers to be equal to each other, x must equal 2 and y must equal 6.